So we'll be starting off with logarithms. So we're discussing about logarithms. So let us start off with say 2 power 2 into 2 cube. What is this equal to?
2 to the power 6.
2 power 5.
2
2 power 5.
2 power
Anybody
5.
had a doubt whether this is 2 power 6? So just to be specific, I think if it's 2 power a into 2 power b, what is this?
2 power
2
a
power
plus
a
b.
plus b.
Power a plus b.
Yeah, a plus b. Please do not write as a into b. This is a plus b, right? So I think the usual law of indices, what you would have learned is a power m into a power n is equal to a power n plus n. Using this, right? So this is exponents, right? So look at this. If I say 10 power 1, we know that this is 10, right? So if I say 10 power 2, we know this is 100. Correct? Correct. So what about say 10 power something, okay, is equal to say 60? Is there an x such that we are going to get 60? Thought about it. For example, if I say 10 power x is equal to say 1, I'll add some zeros. What is x now? What is x now?
6.
6, right? Because 10 power x is equal to 10 power 6, correct? You're able to equate, so you're saying x is 6, correct? No doubts there. Fine. But what about this? Now, if I say, give a statement like this, 10 power x is 60, right? First, is there an x where this is 60? That will be our first doubt, right? If it's there, how can we find it? What do you think? There is an x?
Yes.
Yes, yes. Okay. Anybody who thinks there's no x? Okay. There is a value. Everybody agrees. Okay. Can you give me an idea what that value can be? Approximate. This is rough.
Between 1 and 2.
Between 1 and 2. Everybody agrees with this.
Yes, sir.
Yeah, between 1 and 2. Or is there any doubt? Why should it be between 1 and 2 or something like that? What is the justification, Siri? Why should it be between 1 and 2?
10 power 1 is 10 and 10 square is 100. So 60 is between 10 and 100.
Okay, so she's saying this is 10, this is 100. The value we got is 60 is between them, right? So her argument is, we are not particularly sure it's a function, valid function, but her argument is this is 1 and we are going to 2. So here, this should be a value between 1 and 2. Okay. A logical argument, if you look at, if you see the function is continuously increasing like this, so at 10 it was 10, then it's 100, so on, right? It's increasing, right? So there is some value in between which is equal to 60. I don't know what value it is, right? But at least some rough idea, it is between 1 and 2 for sure, right? Something like that. Okay. Now this is the reason now we need this logarithms, right? To figure out what this value is. Okay. To figure out what this value is. Okay. Just look at this. The same statement can be written as x is equal to say log 60 base 10. Okay. Just make a note. Okay. In general, this is so. To be specific, if I say 10 power x is equal to y, okay, I'm going to tell write the same statement as x is equal to log say y base 10. Okay. And there are different ways. I think different constants are used, say x, a, and so on, but the idea is same. Is this fine? At least the writing part, right? Writing part is fine. Okay.
Yes.
Okay. So suppose, say, I'll just write the statement here, right? So x is equal to log, say, 100 base 10. Can you tell me what x is? Can you tell me what x is?
2.
2. Everybody gets this? So, to anybody has a doubt how to figure out what is the answer? So if you have a doubt, please ask, okay? Because if you are not asking, I'll assume that it's clear. Okay. So look at this. So by definition, I said both these statements are one and the same, right? By definition, what I'm asking is 10 power x should be equal to 100, correct? So when is this true? This is true when x is equal to 2, right? This is true when x is equal to 2. So can you see that we found out the value of log 100 base 10, right? So probably the first value which we could figure out. So let us try to make a note, then we'll understand more about logarithms. Okay. So what did we figure out? Log 100 base 10 is equal to 2. This is what we are able to figure out, right? Yes, Stuti, is it clear?
How to calculate it, I didn't understand.
So when is this statement true? When is this statement true?
When x is 2.
When x is 2, right? I told you this statement is same as this statement, correct? So here also x should be 2, correct? So what I do, whatever statement is given, I'll convert it into this form for now, till we learn more about logarithms. Okay, then figure out the answer. So now the problem is, if I ask you something like this, even though you try to convert it, you don't know the answer, right? Okay, you don't know the answer, but it's fine. At least for standard numbers, let's try to figure out. Okay, then we'll go back. Let's see. Log 100 is done. So quickly tell me, log 10 base 10. What is this equal to?
1.
Okay. Everybody agrees it's 1. Everybody agrees it's 1. Sure. Okay. Okay. Let's see. Log, say, 5 base 5. What is this equal to?
1.
1. Still 1. Okay. So just to confirm, a log of, say, minus 3 base minus 3. What is this?
1.
1, right? Right now it's 1, right? Based on our definition. Okay. Any issues here? Anybody has an objection? Just to make a note, this won't be true. Okay, this won't be true later on while we complete the definition of logarithm. But for now, let's keep it as 1, because based on what we have roughly defined, right? It looks like 1, correct? Based on the definition, what we have done till now, there's no issue here, right? It should be valid for now at least. Okay. So generally, if a is any number in general, what is this equal to?
1.
1, right? 1. So can we look at a simple property? We can see log base a base a is always 1, right? We're trying to define some of these things. We'll start off. So one thing here, how do we pronounce, right, while writing this thing? We say log a base a, right? So suppose we have a different base. So we say log a base b, right? This is how we say. Okay. So what is this? This is called your base. Okay. This is usually called as the argument, but there might be different names you might use in different textbooks, but usually it's the argument, right? Okay. So there's something called a base, similar to your index part. I think here also you call this as base, right? Right. This is your base and this is the index, I guess, right? These are names. You can see that the base part is going here. So again, still that remains as your base. Okay. There's still a link between your exponential and logarithms. Okay. Okay. So let's see. Some more examples. Say log 4 base 2. Right? Got it? Yes. 2. Right? We're saying it's 2. Fine. Say log 27 base 3. Ashutosh, what's your answer? Okay, it's 3. Fine. Now, what about log, say, 1 by 3 base 3? Fine. Dhruva, what's your answer?
I think it's -1 because 3 has to be raised to the power of -1 to be equal to 1 by 3.
Okay. Fine. So now one more question. I just have a question. So if my base is say 4, I want my answer to be -3. Can anybody tell me what the argument should be? I want my answer to be -3. Can anybody tell me what the argument should be? Reciprocal of 4 cube, 1 by 64. B has 2 values. What are 2 values? Let's see. So I think many of you figured it out. So it's 1 by 64, right? 1 by 64. So or some people are saying 1 by 4 cube. Yeah, both are one and the same. So base 4. This is the same. Okay. So from this, we have seen a lot of examples. Any rough guess what is this property? We have written down one property here, right? So can I guess what this property is? What is the pattern here? What pattern do you see? Karthik, can you make a guess?
Yeah.
Root of a given number. Yeah, somewhat, right? Root of a given number, but okay. Yes, one of you has answered. It's better if you answer directly. I'm not going to look into the chat. You can answer right or wrong. It's fine, right? It's easier for me. Any guesses? Or do we need to see some more examples?
Got
Yes.
It's basically like if there's an exponential function, the order of a power x equals b.
Okay.
We represent it as log b of base a.
Log b of base a. Okay.
Is the same as, okay, if that log is the same as, what am I telling? X is equal to log a of, b of, oh shit, log b of base a, then it's the same as a power x equals b.
Yeah, but can you simply remove this b and give me a better argument here?
A power x.
A power x, right? What you're trying to say is a power x, right?
Yes.
So suppose log a power x base a. What is the answer we are gonna get? It's always x, correct? We've already seen this, right? Every time it was x. Don't you think so? This is what we are trying to figure out, right? So even see here, for example, in this example, you were looking at 2 power x is equal to 4. So x was 2. Right? Here what we are reading. Here again, 3 power x is equal to 1 by 3, which is nothing but 3 power minus 1. So the answer x was minus 1. Now, if you look at this, again, we are telling a power x or some variable, let me say, y dash, a power y dash, or let me take it as y itself. A power y is equal to a power x, so y is equal to x. Right? By definition itself. See, all these are properties. They are taught as properties, and you people simply sit and by heart those, right? Instead, everything follows from the definition, right? we just see some examples. We just learn the definition properly, right? I think rest of the things, everything related to logarithms, you can figure out on your own. Okay, need not by heart them as formula. Okay, if something is not clear, please ask. So right now, just by taking examples, we are able to figure out this and this. I hope these two are clear.
So I'm little bit.
Now we have seen rough examples, right? Now let us go back. Let us understand this 2 power x properly first. Then again we'll come back. Okay, right. So writing this in the other form, right? This is what we are saying. X is equal to say log y base 2. That's fine. That's fine. The same thing. Okay. Now I just want to see how this graph behaves. Okay, there are people. Now, do you know how the graph of y equal to 2 power x looks like? Any idea?
Yeah.
Yes, sir.
Yes.
Okay. Can everybody, I don't know, quickly draw this once? A rough sketch would do a graph of y equal to 2 power x. Just a rough sketch of y equal to 2 power x. If you still have it out exactly, plotting, just take some examples, right? Just take x equal to 1 and see. This is nothing but a usual way. X is 1. That time, what is y? When I put x equal to 1, I'm going to get y2. Right? So take some more examples. Just plot it. See what the graph looks like. Just to draw them. Say at 0, this is 1. I think this is clear. I guess 2 power 0 is 1, right? Right. So 2 power 1, just a rough sketch, it's going to 2, right? Just double of this value. Then at 2, I think we know how exponent function works. So it's increasing. It will increase at a greater pace, correct? Next, it will go somewhere here and something like that. So it will shoot something like this upwards. Fine. For negative side, what will happen? Negative side.
It will go towards infinity and towards 0.
It
In
will
the
reach,
y-axis.
yeah. So if I take -1, -1 is what? 2 power -1. This is half. Correct? Half is exactly midway here. Okay. Now if I take -2, again it is half of that value, which is 1/4. So you can see it will continue. It will come closer to y-axis. Yeah, it will come very close to. But I don't think ever it will touch y-axis. Correct? Because I don't see a point where this can be equal to 0. Fine. Fine. Why did we draw the graph of 2 power? See, let me just write it down, 2 power x here. Okay. Now, we have taken different values of x, right? We've taken all the values, let's say, from -infinity to infinity, all the values you have taken, correct? But did we get any negative y?
No.
No, y is always positive, right? So can you see that? Can you see that? If y is positive, how will I get a negative y here? Right? Not possible. Are you able to follow?
Yeah.
Yeah. So let me there. I think the argument is y. Will it change? But let me simply write it here. Say, let me just write it in terms of a and b, so that we're not confusing with the same x and y. Okay. So a and b. So I'm saying that a should be always greater than 0. This is given, right? This is understood now. This is how they define logarithms, but they don't tell you why. Correct. They randomly tell you that this should be positive, just to be clear. So now you're defining it like this. Logarithm is nothing but the inverse of your exponentiation, right? So what happens in exponents, it keeps on increasing at a rapid pace. Here the pace decreases. Okay, we'll see that. Look at this. Have you seen this example, right? 10 base 10 was what? 1, correct? 1. What
Yes.
about log 100 base 10. What is this? 2.
2.
Log 1000 base 10.
3.
3, right? Now, can you see this? It was 10 when 10 to 100 when it went. This went from 1 to 2. Okay. Okay. Now look, from 100 to 1000 when we go, it's just going from 2 to 3. Okay. You can see the decrease there, right? It's just reverse of what happens in exponents. Okay. Fine. So can we see that this is always positive? Okay. One more part is there. They say that this a should not be equal to 1 also. Is that there somewhere?
Yes.
Okay, that's not true. So that's why, see, if you randomly remember, this is how we forget. Actually, it's b not equal to 1, not a, right?
Yeah.
We can't have the base equal to 1, not the argument. Can anybody think of why? Why? What is the issue?
1 power anything
Won't
will be
the-
1.
Yeah, it won't be a function anymore.
Okay, 1 for anything will be 1. Okay, let's see. So we are saying if I take this as a 5 and 1, right? I want to write this in a different way. So I'll write 1 power something. So where is say 1 power 5? Let me write this so that it's clear. Else I'm a bit confused. Okay, let me write the original definition first. So 1 power say 5. This is equal to 1, correct? Right? So any number I take should be equal to 1. So this means what? 5 is equal to log say 1 base 1. Right? Can you see the issue already? Otherwise, I can write 1 power 7 is equal to 1. 7 is equal to log 1 base 1. Again, already a contradiction, correct? You're taking two different values, and there are infinitely many values, right? It can be any number. So therefore, these are all well thought of. So in the definition, whenever I'm writing, A should be positive and B should not be equal to 1. There's one more condition. There's one more condition. What is it? Some of you have already read, I can figure out.
Yes.
So what is the other condition?
B should be greater than 0, but there are some exceptions. I mean, but it's
B-
not. B should be greater than 0. Yeah.
Yeah. What are the exceptions? Okay, we'll get
I mean,
to
no. That exceptions, it's not defined anyways.
yeah. Okay. Why should we be greater than 0 now? Any justification for that? I've given you proper. I hope this is clear. We know why this should be positive, right? It's not randomly given, right? It should be meaningful. We know why this. Can anybody explain why B also should be positive?
Because -2 to the power of any like √2 or something
My -2. Yes. Can you complete the argument?
to the power of √2 or something. I mean, yeah, that.
But why do I thinking √2? Think of some proper number, right? Why should it be √2?
Yeah, we can think of 3, but here
Yeah.
we get the answer.
Okay. So you're saying, okay, if I take a positive number of √2, it's fine. It's fine, you're saying, right?
Yes.
This is what you're saying. But if I take a negative number of √2, it's not valid, is what you're saying?
No, the complex number comes into the picture. I mean, we don't take not necessary of √2. We can take a rational. It's clearly visible in rational.
Rational, yeah. Okay, that's why I asked. What is the exact example you are trying to explain? Can you tell me an example? Like, what should be the power?
Okay, for 3
Power
by
should be even.
Power should be even. 2 and 2. What is the issue here?
if power is odd, also we can get it.
Like what exactly? I know what you're trying to convince, but you're not putting it in a statement, right?
Yeah,
So
if
can you-
powers are even, we get for 2 inputs, we get the same output.
Okay, so you're
Logarithm is
saying
the
it's not
inverse.
a function. That's your justification.
That's
It's not.
one.
But initially you started off with something else, right?
Initially, I started telling that complex numbers might come,
Yeah.
pop out.
Don't you think complex number will come?
Yeah, it might come if there's rational powers.
Yeah. What exactly is the example? Is what I'm asking.
3 by 2. I think it
3
should
by
be.
2. Okay. I think simply you're thinking of square roots, right? Half
Yeah.
is square root, correct?
Yes.
Instead of going square root of 2 in the power, I think taking it to the power of half would do, right? So I think yes, one of the justification what you're saying is, suppose we have this means what? This is square root of -2, correct? So we are leaving the
Right.
domain, right? We are leaving the real domain. And second argument is this, if this is equal to this whole square you're talking about, this is equal to 4, correct? Now you're saying it's not a function. Why exactly? Yes, it's not a function.
Here for two different inputs, that is -2 and 2, we get the same output 4.
Okay.
Yeah.
So
Whereas
you're-
logarithm is basically the inverse of exponents, right?
okay. So here it's fine. This is well defined. Well defined. So what we're saying, -2 is giving 4 and 2 is giving 4. It's not an issue. Okay. Why? Because this is a function. It can be a function. Two different values can give me 4. No issues there. Okay.
Oh yeah.
Yes.
Yeah,
One
but-
value can't give two outputs.
Yeah, but when I told you logarithm is the inverse function, right? Inverse, the reverse process of what we are doing, right? So when we do that, this 4, if it gives two different value, it won't be a function. Can you see that? So see what exponent was doing is this function, when I put x, say it was giving some output y, correct. Random, whatever this function is, actually exponential function, say a power x. I don't want to confuse you with a power x. Say a power b. The variables are different here. Okay, I'm just randomly putting a function. So now I'm saying logarithm function takes in y and gives out x. This is again a function, right? It's again a function. Okay. Now, but when you put a negative number, and just because you have learned functions, I'm just explaining now. Otherwise, I would have skipped this argument. Now, if you're saying two different values are giving you 4, right? And the reverse function should give you two different values. This won't be a function. No, so I can't have that. Okay. So is it clear now? Is the definition clear now? So whenever I'm talking about logarithms, I'm saying that the argument is always positive. Okay. So let me write it down. Say, yeah, log a base b. So I'm saying that a is always greater than 0, b is not equal to 1, and b is greater than 0. Then only I'm talking about this, say some y is equal to a. Okay. So usually we represent something like this. We say log x base a. Okay. A is greater than 0. Then we say x is greater than 0 and a is not equal to. Why x and y? Because usually we plot the graph in the number line. That's all. There's no specific reason to be x and y. Okay. We have seen y. Basically, just I think directly they give you this, right? So just to make you understand it, everything is there for a reason, right? So this is the definition of logarithms, right? Is it clear? Now we have seen a lot of examples also, right? I think after that, we even established something like this. I think, let me just note it down because we have done is equal to 1, correct? This is equal to 1. When the base and argument is same, it's equal to 1. But I think we had seen an example here. This example, can you see that? Now, I told you this is not valid. Now you understood why it's not valid, correct? This function is not defined. It's not defined for this, not defined for this also, right? Neither for the base nor for the argument. Therefore, this is not equal to 1. This is not defined. That's all. Is it clear now? Okay. So whenever I write a logarithm, even if I write this is true, obviously, when a is greater than 0 and a not equal to 1. This is given. We don't write the complete statement, but it is understood. Whenever we write an equation, we assume that it is where it is defined, we're trying to find a value, right? Okay. Whenever I write 1 by x, I'm assuming that x is not 0. Okay. So even though I'm writing the function 1 by x, I'm assuming that x cannot be 0. Okay. Otherwise, you have to specify that x is not equal to 0, something like this. Is that fine?
Yes.
Yeah. Okay. So some more, I think I'll just list down this property. I think it's a new topic. Some of you might be finding it difficult. So if it's something is not clear, please ask here because others I'll be continuing. Okay. what was the other property we figured out? So a power m, okay, base a, this we said is m. Again, when the logarithm is defined, right? Again, you might say I can take a to be negative here and the whole square might be positive. Again, it's there in the base, etc. Just when it is defined, just be careful. That's all. One more question. Log 1 base a. Can anybody tell me what is this equal to?
0.
0. Anybody else? Still think it's 0.
So it's 0, sir.
0. 0. Anybody thinks of a different value or as a doubt? Whatever a might be, doesn't matter.
Right. The similar restrictions are there here.
Yeah. Whenever I say a, it's where it's defined, right? Obviously, where it's defined. So
But when a is equal to 1, what happens?
it's a is not defined at 1, right? So that's what I said,
Yeah.
where it's defined. So whenever
I
I'm
know.
talking about log, I'm talking about these conditions always. So it's okay. Everybody agrees it's 0 then. Okay, those have a doubt. Let's just see. So by definition, I want a power x to be equal to 1. When is this possible? This is possible only when x is equal to 0, correct? No other doubt. Yeah, right. No other doubt. So this should be, again, this is one of the properties, right? Say log 1 base a, it doesn't matter what a is, as long as it's greater than 0 and not equal to 1. Correct? This is 0. Is it fine? Okay. Now, we have seen log, okay, log of some argument and some base, correct? We've seen this equal to some negative number, right? Negative number. So when do we actually get this negative number?
When things are fractional.
It's a fraction, okay. It's a fraction. Now, can we be in fraction? Okay. In fraction. Many people are saying in fraction. Can we be more specific? What kind of fraction? Any fraction will do.
Less than 1.
Less than 1. Is that true? Always. If it's less than
Oh,
1.
that's a root, right? Sorry. Can you assign variables for the brackets just to avoid confusion?
Okay, let's say we want this to be negative. This is a and this is x will continue the same. Yeah.
If a is greater than 1, x is less than 1.
If a is greater than 1 and
X is less than 1.
x
If the
is
result is negative.
okay. If a is greater than 1 and a is x is less than 1.
Or
Also, the
or x equals to 1 by a power m.
X equals 1 by a power m. Okay. So yeah, this example you have seen. It's,
where m is positive.
yeah. This is specific, right? This is very specific. This is true, yes. You have seen that here somewhere. I think negative values you have taken to the power, right? So you have got a negative answer, right? Here also you got a negative answer. When it's a power m, when m is negative, you're going to get negative. That is a generic way. It's true. But like this, some conditions. Why is this true, Sri? Can you explain?
If we take log x base a to be some value, like some negative value, so a to the power y, where y is negative, it would be
Okay.
so it would be 1 by a power x.
So you're saying a power negative value should be equal to x, correct? This is what you're saying. Okay. So you're saying if a is greater than 1, then x should be less than 1. Are everybody able to follow here?
I think we can put one more condition like that.
Yeah. Then what is the other condition?
Maybe a is less than 1, x is greater than 1.
We'll check for that. Just cross check. Might be.
It depends. I mean, the range.
Might be. No, is this clear? Is this clear? This part is clear for others. So greater than 1 and less than 1. See, why greater than 1? See, we'll have, say, 2 power, some negative power. So it will be in the denominator, right? It will be something like this. So it will be a number less than 1, always. Okay, that's the condition. If you're able to figure out, it's fine. Is there any other condition?
A is less than 1, x is greater than 1.
A is less than 1 and x is greater than 1. This is also true, actually. This is little difficult for others to analyze, right?
Take one example, log 3 to the base 1 by 3.
Log 3 to the base 1 by 3. Yes. Yes, this is true. This is 3. This is again what is this equal to? You can write this as 3 power minus 1 again. Correct. So that time it will be 1 by 3. But there are a lot of other properties to add before this. Okay. I'm just looking at this equation here. Again, this equation. Right. Is this part clear? Are others able to follow? Others will look at something else. We'll try to get it. Any doubts here? Clear. Okay, great. Fine. Okay. For examples, let us take the specific part. So A is greater than 1. We'll take that first. Log A is greater than 1 is 3. I think 1 by 3. Okay. This is less than 1. We have seen this is negative value. Correct? Correct. Now, similarly, the reverse factor, now say log of, say, what is this? Say the reverse, I think I can take 1 by 4 and 4. What is this equal to? If you use the definition again, there are other properties to get the answer. Do not worry, we'll learn that later. But right now, directly using the definition, again 1 by 4, say 1 by 4 power x, right, should be equal to 4. Correct. 1 by 4 power x should be equal to 4. Or 4 power minus x should be equal to 4 power 1. Or again, x should be equal to minus 1. That's the answer you're going to get, right? So still you can see that it's negative. Now you may ask, why do you choose numbers 3 and 1 by 3 only? You choose any number you like. The only problem you will find is you don't know the value of that log. That's why I'm finding, because we know this property, right? Which is that log of a power m. We know this property. That's why I'm giving such numbers. Other values you are not able to figure out. That's why I'm not giving. You can take powers if you like. If you can take any powers you like. Say a log of 1 by 2 and 2 power 8. Doesn't matter. As long as base and this has same powers, you are able to get the answer. Okay. Even if you're not able to get the answer, suppose I take say 101. Even if I take 101, you're not able to figure out the answer, but certainly I can tell you that this is a negative number. There? Still have a doubt? So let's see, half whole power x is equal to 101. Isn't this what we are trying to figure out? Can you tell me, for a positive number, can you get 101? No way, right? Any positive number you take, it will be half, then it will keep on increasing, decreasing, correct?
Yeah.
So only way I can get 101 is negative. Correct. See, what we are trying to do is only by the definition, we are trying to figure out whatever things we know about logarithms, right? Just using definition, nothing else. Not getting formulas, not using anything else. Just by looking at definition, what the definition says, we're trying to figure out things. That's all. So this is true and this is true. Can we note that down? Again, so I'm saying log of say some x base a is a negative number when say a is greater than 1 and x is less than 1. So correct? Yeah. Okay. Or say a is less than 1 and x is greater than 1. Fine. So I think it's obvious, right? It's positive when a is greater than 1 and x is greater than 1, or a is less than 1 and x is less than 1. I don't know. It need not be obvious, but because the other part might contain some negative values. But I think we have established that, right? If not, future we'll see if there are any special cases which comes under, even there are negative numbers here. Is it possible? All those things you can see. I think by definition, again, you can follow and complete that argument. If we're still having doubts, then probably you can take that. Okay. Is it fine? So learned a lot of things about logarithms, right? Some of the properties we have learned, right? So can you people try to draw the graph of logarithm? Huh? I'll give you a base. So y is equal to log x, say base 2. Base 2. Can you people try this, drawing a graph? Yes, you can leave. Yeah. That you already know. That's why. Yeah. Please plot it once, right? Based on. So everybody were able to figure something out, some graph.
Yeah.
Yeah. Okay. Some rough sketch. Let us look. I think we tried to draw the graph here itself. Right. I think one of the points were clear, right? Let me just change the color. You've seen log 1, irrespective of a was 0. Okay, let me just write down what we are trying. A log, let me write it here itself. So that this was the first part, so graph which we drew. So second, so y equal to log x base 2. So that x can remain the same. That's the only reason. So when 1, we are saying it's 0. So what is log 2 base 2? It's 1, right?
1.
Yeah. So 1 is somewhere here. Okay. So 3, I don't know. We don't know the value. Let's see. What about log 4? Log 4 we know. Right? It's 2, correct. So log 4 is somewhere here. So exactly 2. So a rough sketch here. I think it's going something like this, right? I think you can continue at 8, it will be 3. So it will go slow, something like this. If you do more points. So 8 is somewhere double this value here. It should go 3 from there, right? So this value should match here, somewhere here. Okay. What will happen for the negative side? Any idea what will happen to the negative side? Negative side.
There is nothing in the negative side of the x-axis.
Yeah, there's nothing on the negative side of the x-axis because it's not defined, right? We clearly saw that. We told that this should be certainly greater than 0. Then only it's defined. So we won't have any graph on this side. Okay, we won't have any graph on this side. So here between 0 and 1, again we can divide this into half. So we know what is log half base 2. Right? 2 power minus 1. So it will be minus 1 somewhere here. So it will be minus 1. Next we know is 1 by 4. Correct. So so at 1 by 4 somewhere here, half of this, it's going to be 2. Then you can see that the same pattern will continue. It will never touch y-axis, but it will continue something like this. So just to draw something smoother, I'll just if I erase this. Right? I hope you people got the same graph. Okay. Or something similar. It's fine. So the idea here is, so look at this graph, you'll get to know a lot of things about the graph, right? So how it behaves, what happened. So that time we were thinking about what will happen for the number, right, here somewhere, when it's equal to 70, right, or 60 here, 10 power x, correct? We are just trying to figure out it's a number between 1 and 2 for now, right? Similarly, if you are saying this, it's equal to power x is equal to 3 or something, we're trying to figure that out. Okay. Similarly for log, so there are numbers in between. So from 2 to 4, we're going 2 to 4 just because these are standard values which we know, but there are values in between. Okay. We directly may not be able to calculate. We will probably need a calculator or a log table to get the exact value, but there are values, right? There are values. It's not so. After 4, we are going to 8. Yes, certainly. At 4, it is 2. At 8, it is 3. But there are values. So any number I choose in between will be a number between 2 and 3. That should be clear. Fine. So just look at the graph. It is taking all negative values, right, from minus infinity. Right, it's coming below from starting here. It's going to 0. It's going to 0. Because I'm talking about y, right? Y is nothing but your range, correct? Your output, right? Starting from minus infinity, going to 0. Then again, it's starting from a 0 and it's continuing and going up to infinity. It's going slowly, but it will obviously reach infinity when you take higher numbers, right? Okay. So what is the range of this? Range of this graph? Range. Write it for log. I don't know where the definition here is there. So range in the graph we have established is from minus infinity to infinity, or in other words, a set of real numbers. Okay. Okay. Domain, now if you ask, so these terms we have discussed in functions. So domain, input. So we have seen that it takes input only from 0 to infinity, right? 0 to infinity. So domain will be 0 to infinity and range will be minus infinity. Now just to remember one point, I just fixed a base. And then we are able to draw this graph. Okay. Similarly, I just fixed a base here. Therefore, we are able to draw this graph. Able to follow. So if I put some other base, the graph will be almost similar, but probably it will be much more steeper or something. If I take 3, it might get more steeper, right? Quickly reach infinity. Okay. If I take 4, more quicker, it will be closer to y-axis, right? So 10 probably here, something like this. Right? It will pass through this point, then it will go up quickly. Correct. For anything greater than 1, it's somewhat similar, but there's one change, so that's why I want to take it separately. So if suppose your x, sorry, let me just change it back to y itself. Suppose your y is half power x and not 2 power x. Okay. For 2 power x, we've seen the graph there, how it behaves. Now, if it's half power x, can you try to plot it again? How it looks? We'll see how the graph looks. Because even in logarithms, right, there are two main conditions. Exponents, we usually take this a power x and just confuse ourselves by randomly taking a power x, right? There are two main parts of a power x. Actually, there are more parts if we consider negative numbers, but we're not considering. So mainly a is a number either between 0 and 1, okay, or a is greater than 1, okay. They behave totally different. Okay. So you can't randomly club them and just analyze it together. That's why I'm taking separate cases. That's why I take a specific example of 2 power x and log x base 2. Right? And now I'm taking half power x. And then obviously next I'm going to do that for the log part also. So again, I'm going to analyze log x base half. Log x base. So try that. Why? Because see, entire chapter can be just learned by the definition. Nothing else is required. Okay. So I'm just going to use the definition and just even the whatever points we're trying to plot. Obviously, we have looked at very few examples. Obviously, for a better graph and better analysis, you need more points. That you can always take. Okay. But just using the definition, I think we can finish the chapter. Yes. So just try to plot it. We'll see what will happen. Just again take some sample points and just do it. I'll give you 5 minutes. Say when x is 2, y is 1 by 4. So x, again, I think a common point would be x is 0, y is 1. So I have a negative value just to check. When x is minus 1, this is half power minus 1, which is 2. When x is minus 2, this is 4. Okay? Just rough examples. So at 0, we said it is again 1. So this is 1. At minus 1, you're saying it's 2. So it's double that. And minus 2, it's again 4. So again double. And at 1 we checked, it's half. It's half somewhere here. At 1 by 2, sorry, 2, it's 1 by 4, half of that. I think at 3 we're going to get 1 by 8, again half of that value. I think you have a rough guess what the graph is. I think from here it will continue like this. Come as close to y-axis as possible. Right. Sorry, x-axis as possible. Can draw this curve, it will be a straight line if I just continue. Okay. Anyways, just try. Let me just draw the curve and then try to. And I'll mark those points properly so that I think 1 and this is 1. Minus 1, it's supposed to be 2. Just assume this is 2 and this is 4. Right. Okay. I think this is the graph we're going to get for half power x. Okay. I hope everybody could figure this out, right? And now the confusion, log, right? Log part. Again, we'll take some sample values. Right? Log 1, we said that log 1 doesn't matter what base is, right? It's gonna be 0. Correct? Now when I take half, we said log half base half. Again, log a base a is always 1. Sorry, we're talking about the values. All right? Right? So then some more values, log of 1 by 4. 1 by 4 is nothing but half square, correct? Half square. So by property, we know it's 2. Okay. Similarly, on the other side, just because we know 1/2, what if I take x equal to 2? If I take x equal to 2, this is log 2 base half or 2 power minus 1. So you're going to get minus 1. Correct? Similarly, if I take 4, I'm going to get minus 2. Right? So again, just plotting those points. Let me say, at 2 it was minus 1, so somewhere here. At 4 it was minus 2, somewhere here. So I think at 1 at 0 here. Between 0 and 1 at half, so somewhere at the midpoint at half. So here we are going to reach 1, so same height here. And again, the half between this, we're going to reach 2. Okay. Again, I think you get an idea. So it's going like this somewhere. Right? Again, not touching y-axis, So it's continuing down below, so somewhere here. Again, it's going, but it will go to infinity. It will straighten out, but it will go to infinity. So this is your graph. Right, this is your graph. Any doubts here? Because I think many of you might have gotten different graphs. It's fine. The first plotting. Okay. So just look at this graph, and we have another graph here. It looks different, right? These are different graphs, right? So you have to be very careful. So this is a graph when log x base a is greater than 1. Okay. Just make a note of it. Okay. because this will be true whenever a is greater than 1. Okay. Similarly, this a power x, whenever a is greater than 1, this is how the graph will look like. Because when a is greater than 1, I increase x, it keeps on increasing. That's the reason. You can see that the graph is always continuously increasing. You can see any value of x I increase, it's increasing. Okay. This is the first set. When a is greater than 1, this is a power x and this is log x. Now just look at it. Now look at this graph. Okay. Now when this is a less than 1. Whenever I say less than 1, I mean greater than 0 and less than 1. Okay. Fine. For that a power x, this is the graph. You can see that as soon as I increase x, it will keep on decreasing. Doesn't matter where it is, it will keep on decreasing. Just as I increase, it's a continuously decreasing function. Continuously decreasing. Similarly, for even log, the same argument holds. Again, if I keep on increasing x, it keeps on decreasing. It's something like this. So this graph is true for log x base a when a is between 0 and 1. Is that fine? Is this 2 points clear? Now look at the analysis we have done. I had asked you when it is negative. When it's negative, correct? Correct? You told me when a is greater than 1 and x is less than 1. Can we check that? A is greater than 1 means the first graph, correct? First graph. When a is greater than 1, so this is the graph, and x is less than 1. Can you see that it's negative here?
Yes.
Yes, the y value is negative. Can you see that clearly it's negative? Right? And no other value it's negative. Just make a note. We didn't check for any other value, right? No other value. For all other values, it's greater than 0. Okay, it's above x-axis, greater than 0. Because we're checking y is the output, right? So output is positive. Output is positive. But for less than 1, certainly it's negative. Okay. Now, second condition we said, when a is less than 1, x should be greater than 1. Again, look at this. When this is the graph for a is less than 1, when x is greater than 1, again, see x is greater than 1 is this number line. You can see that again it's negative. Is it fine? This is fine. I just want to show what we have done algebraically makes sense graphically also. Obviously, algebraically, what points are there? That is the point which you are plotting. So obviously, it should make sense. But if you directly remember the graph, right? Probably you can directly just plotting the graph. You can directly write when it's positive, when it's negative. So, okay. Similarly, that follows for the positive part also. So just I'll take the second case. When x is less than 1, so when a is less than 1 and a is less than 1, this is the graph, and x should be less than 1. You can see that only in this region it's positive. Rest of the region it's negative, right? So this is what it forms. Okay. I think that there are a lot of information here. We really need to go back and again go through these things. Okay. So let me just tell you how the start of logarithms. So see, there are two main types which we use. One is called the common logarithms, okay, and natural logarithms. You commonly, there's no rule that you have to use one among these two, but we commonly use one among these. That's it, right? So what is the difference? This is log base to the base 10, right? So the base is fixed, which is 10. And here what we are doing is log to the base e. I hope you know what is e, right? Okay. It's 2.71. It's called as the Euler number, right? So this was actually this logarithm was discovered by he had, I think, written in a book, not Euler, I think John Napier, right, in the 17th century. So he figured out a way, right, to write these things, and he had defined something like this: logarithms. Correct. So that's what we are following. So now base 10 and base E, there are applications for it. Now base 10 is pretty clear for us. Look at this. Look at this. If I just ask you log 10, say base power 1, 2, 3, 4, 6, 8, 9. Can you tell me what this value might be? Approximately, at least. What this value might be.
6. Above 6, below 7.
Above 6, below 7. Correct. Correct. So can you see what is the application? One simple application from this. He's saying this is above 6 and sorry, let me write it down. So this is a number greater than 6 and less than 7. So can you see a simple application here?
Yes.
What is it? Yes, number of digits. Somebody mentioned number of digits, right? So you can see, you can figure out the number of digits easily, right? Somebody gives a log value, probably you can see for base 10 at least. There are other things which we can do, obviously, but at least here, see, without even taking an effort, because it is base 10, so it's easier to calculate that way. Okay. So because we know that log, see, we know that log 10 base, so 10 base 10 is 1 and 100 will be 2, right? So between C and 10 to 99, so all the 2-digit number is going to give me 1 point something, right? It's clear, very clear. Right? Next you can see that log, see, 1000 base 10 is 3. So any number from 100 to 999, that means the 3-digit number is going to give me answer 2 points. It's going to change only at 1000. Right. So they usually sometimes give you that log of A is say 10 point something. Basically, idea to get the number of digits, probably it might help you out sometimes. Right. So now you might ask, what is the application of taking E then? Some random number, right? So, but E power X is a very important function, right? There are a lot of different applications of it. Okay. So this usually we represent as ln, okay, and this we represent as log. So usually if the base is not mentioned, we assume that it's 10 when it's mentioned as log. This is called as lan. So whenever it's given as ln or lan, we assume the base is E. Properties are same. Nothing new you're going to learn in E or base 10. Okay. So for example, if it is base 10 and E, so if it is base E, say, and E square, this is also equal to 2, nothing will change. E cube will be equal to 3, nothing will change. Because E is a number greater than 1, so the first graph, right, this will be a graph for log x base E. Obviously the values will change a bit. It is not 1 at 2. Okay, at 2.71 it will be 1, but that doesn't matter. The graph will be almost similar. You get the idea, correct? Fine. So there are two main parts. Okay. So what we have, okay, they're called common logarithms and natural logarithms. Solve the first and the second part here quickly. So what you have to do, or you can just copy this. Anyways, we'll do it here itself. Right.
Yes, sir.
Can you answer this? These four.
Yes, sir.
Yeah, tell me. What's the answer?
8 raised to x is 5.
Okay, 8 raised to x is equal to 5. Correct. Okay.
3 raised to 1 by 7 is equal to x.
3 raised to 1 by 7 is equal to x. Right. Okay. Yes.
4 raised to negative 2 is 1 by 16.
4 raised to negative 2 is 1 by 16. These all are true, right? You can even cross check. Yes, correct. Yes. What is the last part?
A raised to x is y.
A raised to x is equal to y. So simple terms, you can please look at this. We can simply raise this to this power. That should be equal to the argument. That's all. Okay. Now, because we have gone through the definition enough number of times, I think probably we can relate directly something like this. Okay. Yes, second one. I think somebody else. Trevor, are you here?
by 18 to the power y.
We'll write down the definition first. 3 power x is a, right?
Yes, sir.
Okay. Then what else do we know?
B is equals to 18 power y.
B is equal to 18 power y. Okay. Okay.
So A by B is equals to 3C. So we
Okay.
can write 3x by 18
Y
y is equals to,
3c. Okay.
then divide, like simplify it.
Okay. What's how should I divide and simplify this one? Any idea?
No, sir.
No. Okay.
C equals to log 3x by 18y base 3.
3x. Can we simplify that a bit? Can we simplify that a bit?
Yeah.
Yeah. So how can at least we can write, we have to write c in terms of, okay. Can we write 3 by x by 3 power c is equal to 18 power y? Obviously now we know log, and we could have taken log any point of time. Just to make it little different. So this is 3 power x minus c. Correct. You all agree? Okay.
Yes, sir.
This is 18 power y. Okay. Anything else we can do?
18 power y, we can break it into factors.
Yes, yes, we can break it into factor. What are the factors we are interested in at least?
That will become 2 power y. I mean, yeah, 2 power y is not
Okay, 18 is 9 into 2, correct?
yes.
So 9 I can write in terms of 3 power. I'm just trying to
Square.
simplify a bit, okay? That's all I'm trying. So it's 3 power 2. So 3 power 2y into 2 power y. Okay. So just divide this 3 power 2y on the other side. So it will be 3 power x minus c minus 2y is equal to 2 power.
Sir, I didn't understand that.
Okay, okay. Let us do it from start so that this, I think I'll, where were we here? Okay. So what I'm doing, I'm getting 3 terms to one side, right? I'm writing 18. This is fine, right? Till here is fine, right? 18, there are factors, correct? It's same as 9 into 2 whole power 5.
Yeah.
So it's same as 9 power, let me write 9 power y into 2 power y, correct?
Yes, sir.
Which is same as 3 power 2y into 2 power y.
Yes.
Okay. So what the other side is a power b minus law of indices again. So a power m by a power n, a power m minus n. So 3 minus x. Now again, this I'm getting to the other side. So it is 3 power 2y. So now it is 3 power x minus c minus 2y. Is it clear now?
So,
Yeah. Now, but we are asked to write c in terms of x and y. Okay. What next? What next? What do we do now?
sir, instead of this, we could just do log before only.
Yeah, we could have done. There's no this just because I think this is the exercise was at the starting point, right? I just wanted to simplify and see, and then figure out by taking log what will happen. Here also we can continue. What is the issue? Any issue here? Where do you want to take log? Where did you want to take log somewhere before? I'm not able to follow. You're saying take log here.
Yes, sir.
Okay.
Yeah.
What log do you want me to take here?
Log of base 3.
Log of base 3. Shall we try that? Okay, let's see. If you want that. So log of base 3. So 3
Yeah.
by, okay, you're saying stop it here. Yeah, this will be great, I guess. So you're saying 3 power x. by 18 power y is equal to c. Yeah. Okay. Makes sense.
We can arrive at the same thing using that, but that's just like
Yeah, yeah, yeah.
circle.
Cool, and I thought they wanted us to get some factor, but I realized now that C is independent of everything. If they probably had asked y in terms of x and c, okay, then probably it would have been clean if you had done here. I think just because it is c, you can take log here itself. So this part is not required. Okay, so directly taking log here would make sense. Okay. Yes, I hope it's clear. I hope it's clear. Okay. What is the solution for this? Solve this equation basically. Ln 2x equal to 3. What is x equal to? What is x equal to? Okay.
E power 3 by 2.
E power 3 by 2. Is it e power 3 whole divided by 2 or e power 3 by 2?
Yeah, e power 3 whole divided by 2.
Okay. Saurav, what do you think?
Yes.
Yeah. What do you think the answer is?
E power 3 by 2.
E power 3 by 2. Tell me what are the steps, how to get it? Why is it e power 3 by 2?
So index of
Yeah.
so the general definition.
General definition. What is this LAN? LAN means what?
So LAN is like logarithm with key.
Huh? You don't know what is LAN? I'll explain clearly, right? So log, if the base is e, it's called LAN, right? That's what I've been telling. Natural logarithm. Fine. So how did you get e power 3 by 2? Somebody said you repeated. So this is the equation, correct? This is the equation. So we simply write the definition. We can see, we can write this as 2 power 2x is equal to e power 3 by definition, correct? Again, once you write down e, then there's no difference, right? But the answer is nothing but x is equal to e power 3 whole divided by 2. That's it. Not a standard answer, but yeah, by definition, what we are able to solve, that will be our answer. Okay. Second one, what is the answer? A. -4 or 4. Okay. Okay. Yes.
Equal to 4.
Yes. Yes. Sai, can you tell me why should it be -4 or 4? Any?
Because -4 square is also 16, plus 4 square is also 16. It's
Okay. Okay.
perfect.
So you're saying that this I can write it as a square is equal to 16. This is what you're saying.
Yes, sir.
Okay. But didn't we discuss this? What can the value of a be?
A can be large. Sorry, sir, I don't get you.
Okay. So see, the base can be only positive, correct? We have discussed this, right?
Yes, so it's 4.
Even though we are getting plus or -4 here, right? So this answer is only +4. Okay.
Yes, I got it, sir.
Yeah. So even though see this is equivalent to this, doesn't mean that our definition can be not defined, right? Definition should be defined first.
Yes,
So
sir.
whatever solutions you're getting, please cross-check in the original equation whether it's well defined. This is one of the tricks used in logarithm. It's not defined, but usually people write it as plus or -4. Okay. So your answer, even though it's equivalent, the answer is only +4. Okay. Here, okay, I think the same is explained here. Okay. Solve for each of these. Okay, let's finish it off here. Solve all these three equations. Then probably you can take up in the next class. It's not that difficult. Then I think you can take the homework as the exercise problem. After the special properties, okay. First property, loss. Okay, till here we are covered. Okay, great. Yes, somebody new. Rashmi, can you answer? Are these people there in the class? Srisha? The people not responding can be removed. Srisha not there. Okay. Shravan? Speak. Answers. Your mic is not detected. I think that's an issue. So again, those who are not having mic, etc., please do not attend tomorrow. So if you sort it out, then attend my class. I think if you're sitting for a proper online class, right, all these requirements are required. Others, there's no point in having sitting there and watching. This is not a YouTube video, right? Sit and watch. Atish. Are there?
Yes, sir.
Yeah, can you answer? First one.
The the 3x minus is equal to 7, that one.
Yeah, yeah.
X is equal to 7 to the power 3 by
This is, see, ln is log 3x base 7. Okay. So yeah, how do you write the equivalent equation? This is try to answer. It's fine. It's wrong. That's why
e to the power 7 by 3.
e power 7 is equal to e power 7. Yeah. E power 7 by 3. Why is by 3? Yeah. Now it's this is the equation, correct?
Yeah.
Always do that step so that you won't make a mistake. You said 7 power 3. Okay. This is 3. Okay, fine. Correct. Now it's sorted. So what about the second one?
A square is equal to 36.
Yeah, what is the solution in the
A
solution?
is equal to plus or minus 6.
Yeah, the final solution would be a equal to plus 6, right?
Yeah.
Minus 6 is not defined. Okay, what about the last one?
I didn't solve that.
So
Right.
yeah, 2 minus z is equal to 2 power z. Yes. Any other? Yeah, is this
Sir, it's not defined, sir.
not
Yes.
defined?
One
No
or
No
negative.
solution.
Not defined. No
No
solution.
solution.
Okay. Yes, I couldn't follow. All of you spoke at the same time. Is
No
why is it-
solution,
if
sir.
If
No
you solve,
solution.
yeah,
Okay, no solution. Yeah, that's what I'm waiting for. Justification is one of you.
So we can make it into the form of a quadratic equation, then solving by the formula, we get the answer as 1 or -2, both of which are invalid according to the definition.
Just to confirm, let me write it clearly. Where is the quadratic equation here?
2c
Sir,
square
Z
plus
square.
Huh?
Z square is
Z
equal to 2
square.
minus Z.
Oh, sorry, I wrote 2 over z. Okay, that's what I was confused. Yeah, it's z square, right? Okay. My 2 and z look the same. Probably that's why I wrote. Okay. Yes, now it's a quadratic. Okay, fine. So it's z square plus z minus 2 is equal to 0. And the roots of this equation are z is equal to what?
Z is equal to 1 or Z is equal to -2.
1 or -2. So -2 we can't take base. Again, 1 we cannot take base. So no solution. Great. I hope others are able to follow. Right. So both are not defined. Okay, nice. Yes, I think this we have already seen, and this also we have seen, right? We will generalize this. So log a base a is equal to 1. So we need not do anything. Just simplify. This we'll take up in the next class. Just simplify each of the following. So what is this equal to? Quickly.
0 plus 3 will be 3.
Yeah, 3, right? Okay. What about b? What is b?
$14.
Yes, this is equivalent to 5. This is equivalent to 0. This is equivalent to 9. That's it. So it's 14. Correct. Right. I think that's it. That's it for today's class. Right. Any doubts? Anything was not clear, you can ask me. You can probably discuss right now. Any part is not clear. There are a lot of things we have stuffed today. It's new. So go through it once more and try to solve the exercise problem. There you'll understand whether you're able to follow or not. That's the whole reason to solve the exercise.
So the last two questions, could you repeat again? Like how to get the solution?
This one,
So the last ones.
last one. Okay. This what is this? Log a base a.
1.
1. So what is this? 5. Is it fine?
Yes, sir.
What is log 1? Lan 1. What is a log 1 base a?
0.
Log 1 base a is what? It's here. I think we have discussed, right? Log 1 is 0. Anything one base I take. It doesn't matter if it's lan, log, or log 1 base 100 also is 0. Right? So therefore this is 0. So 0 into 8 is also 0. Again, lan e. Whenever I'm taking lan, that means base is e. So e base e is 1, right? So everything is sorted here. So that's how you're getting it.
Thank you, sir.
Any other doubts? No.